Hi guys, we will present a project made at the Universidad Politécnica de Pachuca that consists of a car with speed change stroke DC motors. Its main objective is to design and implement a robot with differential traction whose functionality is to move in a straight line at constant speed and programmable at the start of operation. The materials that were used were 1 Arduino Mega, 12-volt source, 2 Namiki motors, driver L298N, integrate 74HC14, 2 wheels, jumper cables, and car base made of MDF. As an approach to the solution, we chose to use an Arduino Mega Edition board because this board has multiple inputs for different purposes, apart from being one of the most popular, which makes programming in the Arduino environment a little less complex. It was connected to a power stage, allowing use control of 2 motors, preventing the plate from burning out due to the excess current consumption by the motors. Each one of the elements that compose the robot was considered meticulously, from the materials, design, and others. Within this, taking into account our power source that has feasible weight to perform its operation without cause for retention, obtaining advantage of the weight. Speaking of, isn't the main foundation to pile that has a very adequate weight so that it achieves its function without having effort to walk. The connection is made between the enable port of the driver L298N and the PWM ports of our Arduino. On the other hand, the potentiometer was connected to analog port so that it sends signals and the PWM can convert them, giving absolute control of the speed to the student.
This type of addressing is given by the difference in speeds of the wheels. Traction is also achieved with test Hames wheels. 2 wheels mounted on a single axle are independently propelled and controlled, providing good traction and steering. This system is very useful if we consider the movement ability of the mobile, presenting the possibility of change its orientation without translation movements. The control variables of the system are the angular velocity of the left and right wheels. The different existing kinematic models provide perfectly defined trajectories, and with this we obtained the various positioning. The results obtained were very good since we achieved our object and everything went as planned. We have modification designed for the future so that our robot is more presentable. In the mechanical design of the robot, an arrangement of 4 wheels different tires was used, where 2 of them go in the front and are the ones who have the traction and direction of the robot, and the other 2 in the front caster wheels, which allows us its stability go in a straight line. Coaster wheels have the function of keeping the robot in stability and allowing it to go straining without being divided. We also designed the base of the car and the engines in the SolidWorks program. We are the bases we are later good in assembling. The design of the base gives an operation of a throttle to escalate, which would help you to make it attractive to people, what the people would be interested in it, so we can have a lowering up of this project. Besides that, the base is very practical in reducing the space required for the components that this has integrated.